So hey folks, Assalamu alaikum. I'm Mohammed Shahriar Al Mustaqimitul, and in this session we're basically going to cover some basics about Vertex AI. Okay, so talking about Vertex AI, so what is this? So in general, if you just go to Vertex AI, if you just surely first of all you have to create your Google Cloud account, right? So after that, and for the students who don't know about that, like when you are creating a cloud account, you have to add your credit or debit card, which is dollar endorsed. Okay, now talking about that, now I am assuming you have a Google Cloud account. That's great for us. Now we will basically going to talk about some AutoML tasks right now. So you can tell me or ask me like, okay, what is AutoML or so on. So you can just write down in the comment section like what is AutoML if you know about that. So in general, just to expect, like Google has made it actually accessible for anyone or everyone, that they can actually use actually machine learning AI and so on. Now it is not necessary, like maybe there are a lot of folks from the business background who wants to test some thing, like maybe that person wants to detect something, that person wants to, like there are a lot of tasks we know in machine learning. So it is not necessary like that person need to actually know the total code or need to write down the whole code about like a specific model. Okay, so for those people or obviously for the developers as well, there is something actually Google Cloud has created in the Vertex AI. When you are working with your data sets or when you are working with models, you can basically create your own model, or you can use some models which has already been created. And to be honest, you actually don't need to think about anything like, okay, this specific model or etc etc, what is the confusion matrix and so on. You really don't need to think about it. So if you don't know anything about machine learning and so on, I have actually lots of blogs written on machine learning. You can just read those out, and I will add those in the comment section of my YouTube channel as well. Okay, no worries. Now let's start with our tasks. So today basically we are going to learn about two tasks in general. One will be like vision, AutoML for vision, and one will be for actually natural language tasks. But I will not complete the natural language task, and there are a lot of things that actually goes with these things. So I will just make sure, like there are some models I have already run, so I will just show you the result and so on, and I will surely tell you the process. Because the thing is, even when I wanted to add the data set, it took me like 20 minutes. When I actually started training the model, it took me almost 2 hours. So in a session, it's nearly impossible, like if to continue for 2 hours and just stop doing any other task, right? So I have already done all of the things. I will just make sure you understand how to do it in Vertex AI, and yes, how to see the result. So let's start. So today, talking about our vision. So we are just starting with one of the this is a data set. From here you can see it is basically shoe versus sandal plus versus boot image data set. So we have 15,000 images, and from here you can see 5,000, 5,000, 5,000 images. And okay, that's great. So there are three sets of images: shoe, sandal, and boot. So what is expected from us is to like classification of this problem, like to use some sort of models or whatever it is, so that we can see like this we can create some classification. So if you have if you already know like the like CNN, right, convolutional neural network, etc. So if you just know CNN, you will easily understand. Just you just apply CNN to this whole data set and it will work. Now the biggest problem is 15,000 data. That is huge. Okay, 15,000 data is huge. Now it requires a lot of computing power. So to reduce that, okay, to reduce those issues, what we will do is I will mention like we will basically going to take like 100, 100 and 100, only 300 images from these folders. Okay, So first of all, we can just download those. So yeah, download this one. It will be like 49 MB. Great. I've already downloaded that. Now I will just go into here. Okay, here you can see this is the folder I've downloaded. Now here I've just already extracted the folder, and here you can see we had these 3 folders by default created. Here you can see, if you just go here, you'll see lots of images, right? Like, okay, 5,000 as mentioned, right? You can obviously see it's loading, right? Okay, 5,000 images. Yes, 5,000. Great. So what I have done is I have decided I will take just 300 so that it takes less time. So even though when I run these 300 images for training and so on, it takes almost 2 hours. So you can understand, if I just train it with 5,000 images, it will be like, obviously it will be huge, right? Okay, let's just now talk about this one. Okay, so here you can see I have created another folder which is called mixer, and here I have just kept 100 of every element. Okay, so here if you just look into here, you'll see this is 100, 1 to 100, and then again we have I guess sandals. Yeah, 100 sandals, and again 100 shoes. Great. So all of these. So now our task is to, like, okay, these are the images we have collected in our local system, no issues. Now talking about what to do in Google Cloud. Okay, so talking about what to do in Google Cloud. Now the thing is, you have to keep all of those, either you can do it in your Google Cloud storage, you can keep all of those in the cloud storage, or what you can do is now you can upload that later on. But there are a lot of issues we will be working on, but I'm going to make sure, like, we know, like, here is a training, and here you can see there are 2 trainings right now. Like, this is already I created, and you can see AutoML detection. So training, this has been done, and this is what we are going to show, like show you that how it works. Okay, and this is already training. So you see it has been 2 hours and still it's training. So this is how much time it takes. So if I'm not wrong, it's like 900 sentences out here. So it is basically NLP based some sort of training. We'll talk about that later on, but let's just talk about this one, AutoML detection. So I'm not going to actually hop in for this one, just going to show you like what it takes. So first of all, we will have to mention the data set. So here you can see there are like I have 2 data sets by now. So it is like 300 images and so on. I'm not going to take those. I'm just going to show you, like, first of all, like what it takes. Then we will just show you how we did it. Okay. So 300 images and so on. We need data set. We need a lot of stuff, right? And you can see here, this is the thing we are talking. So this session is basically on AutoML, right? So you can see this is AutoML, right? You can also add your own custom training. So in that matter, you have to add hyperparameters and so on. And we are not bothered. We don't want to be bothered with it. Okay, we don't even want actually know which model we are applying. Okay, Google Cloud will do everything for us. We'll just share the data set and it will basically do that task. Okay, now you can ask like how it does. Now the basic thing is, when you were learning machine learning, you might have learned that, okay, there are a few things like confusion metrics and so on. This is something with which like we basically know, through which we know like how much correct the model is, and depending on that, it is basically training on everything, and the best one will be shown out here. Okay, let it be. Now talking about, it's expected it should be CNN, right? It is not less basic cluster or something. Surely not basic cluster. Not, it's because it's something related to image, and we have to use metrics to transfer and a lot of things, convolution things and so on. Then we will have some data, and using that data we will just apply it to neural network and so on. So I just don't want you to know about this. I just want you to see, okay, how it works in Google Cloud. No sort of coding. There is nothing in this session, at least. Okay, Now, okay, so you saw like we have to actually we need some data set, right? Again, I'm going to see, okay, we have two data sets right now, okay, data sets. So where are the data sets? Here are the data sets, okay. We have already loaded all of those. I will let you know later on, but just when we actually want to create a data set, what are the things we require? Just let's understand. Okay, for images, so we are basically talking about images right now, right? So here you can see we have single label classification, we have multiple label classification, we have object detection, we have segmentation. Great. Now the thing is, like, single label classification, this is something we are basically working on. You can see what is the single label, we will talk about that. Then we have multiple label, we have object detection. So object detection is to detect the object, okay. Segmentation is now you can see exactly the shape, it has taken the exact shape and predict per pixel area, okay. It actually predicts using actually every pixel. And again you can see single label classification, that means maybe that now you can see from the image only this is some sort of triangle, right? So it base it, and we've given some data and we have to give some data and have to say okay, this is a triangle. So it's something, again talking about these, we have multiple things. So you can see multiple labels, triangle and a square as well. Now this is basically from the image it detects it's a triangle, from the image it detects this one. But segmentation is basically it is actually segmenting the triangle and the box, okay. So there are a lot of things, these are the things you can also use your cloud shell, obviously not image but basic sentence based or NLP based something we can work with our cloud shell. Okay, let it be. Now we are basically bothered about this, and now we can say like how to work on these or how it works. So let's just do it. Like let's search for Vertex AI documentation. Okay, great documentation. If you just look into the documentation, if you just look into guides, okay, here you can see image data. Then we are basically looking into classification. So now we have to prepare the data. So we are here, okay. So you can write it in JSON or CSV format, no issues with that. So you see like this is the format we do use. First of all, we actually shared the GCS file path, okay. That means Google Cloud Storage file path. So first of all, we have to upload all of our image to Google Cloud Storage. We have to add that. For example, this is something. A bucket is basically a storage where we keep our data. And then we have to share the label. So what is this label? Label is basically identifying the object, okay. Basically assume like what we are doing currently. We have lots of image, right? We will give all of this image to our model and say every image for every image we will say this is a shoe, this is a boot, and so on and so forth. Now you can say why are we doing that? So in machine learning what happens is we do train just like a child. We do say hey child, this is a tree, this is a bus, or so on. And in real life when that child actually goes for school, he or she detects, okay, this is a bus I have to ride on, this is a tree I have to give some water to it. So this is, so we are basically right now training this. So we have to share every sort of details we know, okay. So this is some sort of, we will basically upload our image and this will be the path. And we will also say if this is a boot image, we will say it is boot, this is another thing, we will say anything, okay. Great. So this is the format we are going to focus on, and at test training we don't need to focus on that. This is basically when you use cloud shell, okay. But we are basically bothered about this thing. Okay, let it be. Now talking about this one, so when we want to create this one, what we have to do, we have to add the data set name. Then when we create this one, we have to add the location of it. So for example, we just want to demo image, okay, data set. Okay, because our target is to like single level, I just mentioned, right, single level, because like talking about a boot, it will surely be just a boot, right? We will just add dot comma boot, okay. Great. Now when we press this, it just gets created, but there is no data out here, right? You know, we have not uploaded anything. Great, the data set has been created, but now it expects us some sort of data, maybe some image actually. Now you can see, if upload image from your computer, we have the option to upload our image from computer. But the problem will be, when we upload our image only, we are not mentioning like this image is a boot or anything. It cannot detect that before that. If you have worked with CNN, you know, like you have to mention that in the data, this image is this and so on. Okay, now we have another option like upload import files from your computer. We want to do that, but we will select import files from cloud storage. Okay, so what we are going to make sure is we are going to upload all of our images to cloud storage, and then this is very tricky part. Okay, now let's go to the cloud storage. Now this is the important factor. Now talking about this, is basically I've created AutoML mixer, and mixer is, you saw, just I created a folder called mixer, that's why I just created this one. Okay, so here we have lots of CSV file and so on, and you can understand what it is. But my main goal is to upload, like here is the important factor we talked about, right? We previously talked about this one, like we have 300, these 300 has been uploaded here. Now you can see, you can ask me how. You can see here 100 of 300, that means 100 is out here, and we have we have actually 300 images. So we have first of all uploaded these. Okay, now we need actually the location of these. So we will use our cloud shell to know specific locations for our images. Okay, let's try again. Okay, let's wait for this one. Okay, great. Right, so what we are expecting is we are going to use some command called gsutil, which is going to use our storage, cloud storage. Okay, great. So we have these folders. You saw when you were entering, we had two folders. So I'm just going to copy this one and gsutil ls within, like I just want to see what is within the mixer folder. So we will have multiple things, but I'm basically focused on this one. Okay, this folder. Great. Okay, within the folder we have 300 images, and you can see that right now. This is the location we are talking about, right? Isn't it? GS colon and so on. So this is the thing. So we have 300 images location, image location of the thing. Now what we have to do, we just have to do is we have to create an like a CSV file. Here we can just do Control V. So all of the images are out here, and you can see, how can you understand? You can see 300 images, right? Now what we can do is we can add our labels. Now you can see this is sandal. So what we can do is write sandal and then copy paste. Have I gone through all of this? Okay. Yes. Okay, sandal. Great. And for this one, it is shoe, right? Okay. Great. Shoe. Then this is boot. Great. Boot. Done. Now, okay, now we have to turn these to a CSV file. So now you can ask, like, brother, what is CSV? CSV basically, okay, these are some sort of, you can see here are some sort of tables. So these things are basically, every data is actually like what I would say, every data is, you can say, is what I would say is something discriminated or divided by some sort of table, a column or so on, right? Now in CSV, what we do is we do add our data and define or discriminate those or divide those depending on some sort of comma. Okay, so what is a CSV and so on. So what we can do is I can just turn it to like maybe save as, and some sort of maybe what I can do is in desktop maybe, and what we can do here, we have CSV, right? book1.csv. In my desktop I've just I already have that, so okay, no, I'm just going to already create this one, book 2. Okay, now we will see how it works. Okay, let me check those out. Desktop, right? So this is the book2.csv file. Okay, now you can't see, like there is no difference for out here. So what we have to do is we have to open this file using notepad. So in that manner it will work. Open with notepad, and here you can see, okay, this is basically the file. You can see the location, and after that we have lots of commas. It should have been just one comma, but it is not. I've tried multiple things, just converting Excel file to CSV. Still it is multiple comma, but we are expecting just one comma. Okay, so how can we do that? Control F, then we will just do is like, okay, yes, we want to replace every, like we have 4 commas, we want to replace this with just one comma. Okay, done. Great. So we have now replaced that. So this has been created, and you can see the name is book2.csv. okay, we can just save that down. Yes, done. Okay. Now our task is to just upload this. Okay, now the thing is, I have already done that previously. So talking about that, okay, so this is not for like our one. Okay, so CSV, so what we can do, I can obviously upload it right now as well, but we can also do another stuff. So let me just take this. This is for this one, CSV. Okay, so as a whole, like we can just upload that. So what I can do, we will have images out here, right? Yes, I just don't want to be here, I just want to be here, and we can just upload that. So upload files. Okay, let me just upload from here, book2.csv. this should be our file, and you can see it will be uploaded. Okay, so I will create the data set and just make you understand how it works. Okay, book2.csv. Now I just need to refresh that, and it will be working. Okay, refresh, and if you just go into here, you will see book2.csv. Okay, so you see like 30.3 KB and something like that. This is our size of the file. Okay, no issues. Now talking about the yeah, this is the thing we were talking about this. So now we can do what we can do, just we can just use book2.csv, and now that, so that book2.csv, what is there inside the book2.csv? We have shared the location of the image in our Google Cloud storage, and also added a label like, okay, this is the image and it is a sandal. Talking about this, the image of shoe, and this is a shoe. These are the things we're just doing that. So it will just start. We can just upload that. It will take some time, maybe 15 minutes and so on. So this is how it works. So assuming that we have already created that, so I've already created that. So yeah, this is getting created for our demo image, but I've already created that, which is AutoML detection. Okay, now after that we will have is like 300 images. I did mention all of the images will be out here. Why? Because we have just shared the location link and all the of the Google Cloud storage. So Google Cloud is connected to it, so it will just show. We can also see the images here as well. You can see 1 to 10 or 100. You can just see that. There is no problem with that. Okay, hundreds of images and so on. Okay, no issues. So only for the boot, this is the boot images, and if you talk about all images, we can also go for that. So we have total 300 images, and 300 of the images has been labeled. You saw like shoe or other things. Okay, and 100 is boot, 100 is sandal, 100 is labeled as shoe. Okay, so it is great. We just have the data. Great for us. Now you see it is taking some time. It will take almost 15 minutes and so on. So we are not going to be bothered about it. Let's just go to the training. Okay, you see, like talking about NLP1, it is still not trained. So you saw, you can just understand now, okay, how much time it takes. Okay, now as we have the data, just assume that these are not existing. We just say like, okay, train the model. So now we can take the images. Now this is the data set is getting created. Okay, it is still not there. That's why just name is there, but no images is uploaded. Assuming when it will be uploaded, it will be something related to that. So we can just take this one, it will be automatically selected. Then we will say okay, AutoML, and we will just continue. Now name, we can just give it any, you can just give it demo training. Okay, then advanced option, this is important. Okay, so when you like assuming if you have worked with machine learning, you know like 80% or 70% of data we use that for training. 10 to 20% data is something we use for our testing, and rest other is for the validation. Why? Okay, just let me give you the example of a child. So a child, when we are like a parent, as a parent what we do is, okay, we just teach the child like, okay, hey, this is a tree, hey, this is a building, this is a door, you have to lock this when you are in your washroom, or when you want to go to some ride, you have to enter into a bus, right? It is better for us. So a lot of things we just use, like we do train. Okay, now the thing is, then in the real life, like maybe or whatever can happen is, maybe there are exams, right? Maybe the teacher can take some exam like, okay, hey, can you detect where is a tree out here or something. It can be taken as a test, and validation is something, maybe it is a real life case, maybe it is not an exam. In the real life, when there is some sort of thing, the child is walking in the street, he might detect, okay, this is a tree. So this is the result, right? We did teach or train the child, the teacher did test, and in the real life the child is successfully able to know, okay, this is a tree. Now the thing is, we are like assuming we have 300 images, so out of that we are going to use maybe 240 or some sort of images for the training. We'll just teach our model, okay, this is something, this image is this image is this, and so on. Later on we will test again with the 10% of the images, and 10% is for the validation. We're just skipping that, you can see from this one. So yes, and model details, yes. Also encryption is Google managed encryption, so Google will look into that. And talking about this, our goal is obviously high accuracy. The low default one is obviously not that much high, and the latency means how much time it will take. Okay, the latency, what I would say, higher latency and something, it means it takes less time or something related to that. I think I may say the opposite one. Okay, so the higher accuracy, it will have less latency, like, okay, it will take very few time, okay, to load something. We'll do it very easily, and there will be, the accuracy will be very high. Okay, there will be like incremental training. Enable incremental training. We don't need to, no, we don't want to do that. It happens when we want to create another training, and we already have some sort of training related to that. We can just choose that. I'm not going to do that. I'm going to show that, okay, this is important, and after that we will just see, okay, here we can say for how many hours it can run. So why are we saying that? Because when you are using cloud, you have to think about the budget, you have to think about how much you are spending. So maybe you have decided we can have like 8 hours, we can let this training for 8 hours, okay, or 5 hours, 6 hours. So if you just give it for 2 hours, it is not a good thing. When we give it like maybe 8 hours, so it is saying like, okay, you have said 8 hours, but it might take 1 hour. So when I do say 10 hours, again 14, it is now, sorry, 14, it is now 13, 1 hour as well. But if we just say 1000 something, it is I think it's not possible for us. And if you say 111 hours, it in general takes 13 hours. So it is basically saying, okay, when you're saying 8 hours, it might take 1 hour, okay. So I just say 8 hours, and then we can just start learning, and the whole thing is done, okay. Whatever I have taught you is like, now it will take 2 hours or something, and it will be trained, okay. This is what it happened in general. So when we did it, it took almost 1 hour and 38 minutes to train, then it stopped, okay. Once it is done, what we do is we create some sort of endpoints, okay. Now this is another thing, like we'll talk about that. So what is this something endpoint and so on, we'll do that, we'll talk about that. But you can see now, after we have done the training, you see like average precision is 0.99, precision is in general 100%. So we have total 300 images. Training images was 250, validation image was 30, test image was 30. And you see from here, it is really an awesome thing, like confusion matrix 100%. It was like, if you know about confusion matrix in general, it is basically saying, okay, just see this one, sandal and sandal. So the true label was sandal, assume for an image, okay. Now we can see like, okay, so what is happening is the true label, like assume just for an image, okay. We have said like this is a sandal, okay. Now the model was run and model saw, okay, it just predicted yes, it is a sandal. And how we predicted, depending on the testing, okay. It also did test, okay. These used basically it started training with 240. After that, it used those test images, and it predicted, and it saw like, okay, we had maybe 30 images. Every time when it was a sandal, it actually detected sandal. So you can see 100%. Again, for the shoe, it was actually 100%. For the boot, it was actually 100%. Totally, that's awesome for us. Like, okay, it is very rare actually. Okay, but still, it's awesome. Okay, now it's done. Now what's expected from us is to test. How can you do that? That's an interesting factor. So from here we have feature store, labeling task. Okay, another important factor about talking about labeling tasks. So we can upload our data and then use this to actually label our task. But you can see Vertex data labeling job is depreciated, so it is basically going to stop for now. So we are expected to actually label our data rather than expect Vertex AI to do that. Okay, running experiments, we can experiment, we are talking about metadata. So previously in one of my session I did mention about metadata, okay. So metadata is basically, it gives us more information, and from model registry we can basically see we can basically deploy our model, okay. So from here and so on, we can do that, like talking about those. Okay, online prediction, then monitoring. We are not using that. Batch prediction, in general, batch prediction is like when you want to predict, but in a mass, like in a huge data set, you can do that. So prompts, tuning, fine tune, vector search, monitoring, online prediction, model registry. Okay, so here we have just one machine learning model by now, so it's great for us. So we have just seen that this is something. So again, talking about these AutoML detection training, this is exactly the same thing that's out there. Okay, you can just come up here. You can also check out the dataset, deploy and test here. So talking about endpoints, we can just, after the training is done, we can just come up here, and I have already deployed this thing. Okay, and actually this is something for which we are charged. Okay, so we can just go to deploy endpoints, and surely we can just give it a name or add to existing endpoints. We already have some sort of endpoints created, and then give the other things that is not important. These are not that much important, but again, you can just give it the name. The location should be where the training was created. It was basically in US Central 1 in general, you could just see, and then continue and so on. Sweet. Okay, we have already created the endpoints. It also takes some 15 to 14 minutes, and once it is done, we are ready to give any sort of image and check those. Okay, if you talk about image, upload images, what I can do is from here, maybe I can check, like, it is a boot, right? You see, this model will not know it from the name of the image. It will just see the image, and it basically is like talking about CNN. If you just have worked with it, you just know about it. So you see what happened. It is saying there is a like 0.001 chances that this is a sandal, 0.004 for shoe, and 0.995 chances that this is a boot. So this is exactly how CNN works. Okay, now I can just give another image, maybe this time from shoe. Even now, interesting factor, I just took first 100 images, so that's why it was so perfect, assuming. And now maybe I'm taking like 384th shoe, which I never give it for training. Okay, now interesting factor is, you see, the shoe, it is again true, like the most percentage is shoe, 0.859, and it is saying like 0.287 is it is a sandal, and boot is 0.113. This is not the data which we uploaded for training and so on. Okay, and I'm just going to again maybe some sort of image which is maybe, like you can see now, it is maybe 866. So it is saying it is a shoe. Again, it's true. Now talking about, because we actually check the most, we to take the more which has the most probability. Okay, now sandal, again some sort of data which we didn't train with. Okay, sandal, yeah, you see 0.792. Still it's not like 90 or something, you see, but still it's like a very good percentage, so that we can say. So this is how we can use our AutoML, and we didn't have to code any single we didn't code a single thing, right? Writing a code or anything. Now talking about that, that's good. So that's the end for our I would say AutoML vision 1 or image classification. Now talking about this training, you see this is still not trained, so I can't show you the result, but I will surely mention you the process how we can do that. So what is this? What are we talking about? So right now we are basically going for a restaurant customer review. Okay, this is a data set. Okay, this is basically from this data set. What is here? You can see, maybe assume that this is some sort of feedback. Okay, these are the reviews. So now in general, there is a saying that in machine learning, the most part of time, like the most probable time, the maximum time it takes is in our data pre-processing. Okay, and others. So here you can see we have, wow, loved this place, right? This sentence is meaning something sort of positive. You can see if it is more positive, if positive it is 1, negative 0. That's good. Just let's see, cursed is not, sorry, I just made a mistake. It's a crust. I was thinking maybe it was cursing. Okay, let it be. Crust is not good. Okay, this is negative for us. Again, I was shocked because no signs indicate cash only. This is negative for us. against, let's say for some positive, this hole in the wall has great Mexican street tacos. And friendly stuff. On a positive note, our server was very attentive and provided great service. Okay, here is an interesting factor. We can also use, like, okay, these are the thing, obviously manually in general we can check these manually in general, or we can use our machine learnings. And so for that, in Google Cloud we have, in Cloud Shell we have something. Let's just check this out. We can just see, like, okay, we can detect the sentiments. Okay, let me clear this out, and I'm going to say G Cloud ML language. Yes, we have like sentiment analysis, right? So I'm going to use G Cloud ML and then analyze sentiment. Okay, paste, and then slash content equal then that sentence. Okay, let's see what it does if this if Google Cloud can detect, okay, what it means. Let's see. Okay, great. You see the score, the whole document. Again, if you just see, like, okay, let me check this out. Like, okay, G Cloud language API, natural language. Yes, something related to natural language. So here, if you see this demo, so you can just paste this here as well. Okay, you just don't need a Google Cloud account. So here in the sentiment you can see it says like 0.93. That's, it shows something positive. That's good for us. Here we have the range from -1 to 1. Okay, -1 means very negative, 1 means very positive. Okay. So again, as it's a negative, frozen parts of this thing, so let's just take it and add it here. Analyze. Okay, sentiment, this is negative. See, so maybe your boss has said, okay, these are the feedbacks, do tell me this is positive, negative. Just come up here in like cloud.googlecloud.com natural language and hash demo, just use it and you will just see if it is 0 or 1. Here you can see -0.884. This is because the range is from -1 to 1, but here for our data set, just for here, it is, we have just given 2, 0 and 1, so that it is easier for us to detect 0 or 1. And you know, like 0 and 1, it is basically some sort of clustering. Okay, now we can just use that. So we can then download this one, like download these files, it will be downloaded. And let me check this out from our folder, and it's basically, so yes, done. Okay, this is the basically folder we have downloaded. Like we have already this is basically, that was a archive folder, then I did extract, and there, this is the file it was there. It is basically a TSV file, restaurant review TSV file. Okay, what is TSV? TSV means basically it is separated by a tab. Tab is, you see, after that there is a huge gap, that is a tab. But in our models we are basically using CSV. It is better for us. Okay, because when you basically work with this one specifically, and talking about TSV, right, when you are creating your own model or writing the code, you will basically if you have done that, I have written already blogs on that, just first of all delete this one. You won't actually you'll say, okay, you don't consider this first row, and then from here consider this is there, this is how the data is separated, and so on. You just need to mention. But in our Google Cloud, we just basically will convert that to actually CSV file. Now you can say, like, how can we do that? So basically you can do that by some sort of online converter from TSV to CSV, and I've seen that it works. Okay, even if it doesn't turn out like maybe a great file, it can again be something related to some sort of just comma and one. Okay, let's just see how it turns out. I've already created that. No, not that one. Let me check this out. Did one. Wait. Wait. Okay, so these are our buckets where we had two sort of data. Book to this is mixer and final.csv. Okay, final something we created this one. Yes, book to was something we created, I think, right now, and so it should be something related to mixer. Okay, let me check this. For our previous data, this is something it would look, but yeah, we have done that like from here to that. I'm just basically checking like how did I convert that one, because this is not the file. If this is not the file, then we can create that for our own. Okay, we can do that. That's not an issue. It is basically restaurant reviews or say something related to that, but I have to wait. Let me check. I think we can do CSV file, right? Okay. Yes, I've got that. Okay, so we have converted that, and now I will show you what it looks. Okay, let me check if this is the one. Yes, great. So we could just use any of the online converters, and what we will do, first of all, TSV to CSV, and you will just see something, but not exactly like that. Maybe in the first row there will be like the review and like or something, that thing we previously have seen. I think how can we see that from the folder, right? Previously, let me check that again just once. Yes, you see like review and liked, this will be there. We will just delete that, and we will have something related to this. You see like it is just comma 1 comma 0 something. So the whole sentence is out here, and after that we have 1 or 0 and so on. Okay, great. Now you will just upload that. This is the file we uploaded, restaurant.csv. Great for us. Now this is the data set, basically like our data and the label out here. And you can say, okay, how did I know, like, okay, we had to do it. So just if you talk about the text data, just the classification prepared data, you just come up here, it was exactly mentioned out here, like you have to mention the path and then you have to add some label. But here we just adding the data right now, exactly the data we are adding. We can do that for sure. We just don't need to add the location out here because it's not image. We can exactly just share the image, share the data. Okay, so then after that vertex here, right? From here what we can do, we can just go to the training. Then let me check if it was, no, it's not, it is still running. You can see it has been 3 hours, but it's still running. So what you can do, you can train a new model, and you can just take the data. This is the restaurant review data, so you can just take that, and then you can just say like, okay, use AutoML and just detect this one. You can do that, then it will start training. Depending on the data, it will train, and then the same thing what happened, like we just work with the endpoint, will then add some sentence, and it will say, it will give us 0 or 1. Okay, that okay, this is a good review or not. That is the thing, that is how this whole training will work. So I think that should be good for us to know, like, okay, how to work with Vertex AI and how to work with AutoML, basically specifically using. And just let me just check you, show you what is happening here. You see, like, this training began at like almost 2:05, and it's like almost 5 p.m. and the status is still training, and we have training pipeline IDs here created on this region. Is a central one. This is our annotation set, this is data split. So when we are creating that, we said 80% of the text you just use it for training, 10% for actually testing, and other will be for the rest of the part. And algorithm is basically AutoML. We have not added our own ML, AutoML. So what is AutoML doing? It is going to choose, it is basically going to use any of the algorithms out here. But if you just look into here again, like in the tags, it is in general mentioned, like is it something, what the kind of algo we are expecting. It is basically neural networks and textual based data, so it's not that much of tough. Basically you can use neural networks, basically ANN and others, just to know like, okay, what sort of things are out there. Okay, that's it, I guess. So that would be it for our Vertex AI session, and thank you so much. If you have any questions, feel free to actually add it in the comment section, and I hope you learned a lot of stuff from for AutoML specifically. And yeah, thank you so much, and see you in the next sessions.